Respectively. So the ideas are still the same, but the syntax looks a little different, and we've just got to ingrain in ourselves ultimately what these patterns are and what these human conventions are. But notice that what we just did follows the same paradigm as last week, but let's add a little more terminology this week. Last week, we described the black box as potentially being algorithms initially, and then we started calling them functions. Functions are just a programmed version of an algorithm, the implementation of an algorithm in code, in software. So a function might be represented here as taking inputs, otherwise known now as arguments. But it turns out that functions can do at least two different types of things in the world of programming. And we've seen these things already, but we didn't describe them quite as particularly as we will today. When a function takes inputs, that is to say arguments, just like hello world is an input to the say block in Scratch or the printf function in C, functions can have what are called side effects. And recall, we did see this last time. When we used the say block, it did output something, but more technically, it had a side effect, a visual side effect. When I used the say block last week and the printf function this week, you see something on the screen. And that is, yes, some form of output, but it's a little different from a different form of output that we saw last time. So a side effect of a function is often something visual that happens on the screen, like text or audio in that case. But there's this other feature of functions that we're going to see and leverage today known as return values, where a function can really just hand you back a value. It's not going to say it on the screen. It's not going to vocalize it audibly. It's going to just pass it back to you in a way that you, the programmer, can reuse whatever the output of that function was, ideally storing it even in a variable. So for instance, recall last week that we asked the human their name by way of this ask block. And the input to the ask block in this white oval was, what's your name? And then recall that this ask block was a little special last week because it gave us access to whatever the human ultimately typed in. And that is to say that the ask block last week essentially returned a value. It didn't just blindly display whatever word the human typed in on the screen. No, it instead returned it in some sense, metaphorically, and stored it in a special variable called answer. And so again, that's the difference. The say block literally says something on the screen, and there's an immediate visual effect. With the ask block, after you type in your name, you don't see your name printed or displayed again on the screen. Instead, your name is sort of tucked away in a variable, just like a mathematician would store a number in a variable like x or y or z. The onus was then on us, the programmer last week, to eventually do something with the value, my name, that was in that variable called answer. So how are we going to translate last week's ask block to C this week? Well, it turns out there's different ways to do this in C, none of which are very easy unless you use what's called a library. A library is code that someone else has written. And indeed, one of the things we'll use today is the so-called CS50 library, which is a bunch of code, not terribly much, that the staff and I wrote just to make it easier to do simple things. These are training wheels of sorts that will take off completely within a few weeks' time. But in order to get started quickly, it's going to make it easier to do things like getting text from the user. So string is a term of art in the programming world. A string is text. It's a word, it's a letter, it's a paragraph, it's a page of text. It's just text in some form. String is what a computer scientist would call text. GetString is a function that we wrote that we will provide to you that does take inputs. Notice, per the parentheses here in C, it can take input. What might that input be? Well, just like the ask block, it's going to be a prompt that the human should ultimately see. So there's a bit more involved, though, than just using this function. When you use getString in C, as we will soon see in a live demo, you want to do something with the human's name. And to do something with the human's name, it's not quite sufficient to just trust that Scratch will put it in a variable for you. In C, as with most programming languages, it's a lot more pedantic. Like if you want something to end up in a variable, you've got to do it yourself. MIT is not going to magically put it in an answer variable for you. You have to do it yourself. So to do this, you simply come up with the name of the variable that you want, be it x or y or z, or more compellingly, answer, and you use an equal sign, a single equal sign. And even though in math this generally implies equality, in the context of C and most programming languages, the equal sign actually means what we'll call assignment. It means effectively copy whatever is on the right into whatever is on the left. So if on the right-hand side there's a function whose purpose in life is to ask the human what their name is, that name is going to get copied from right to left, ultimately, into this variable called answer. MIT did that automatically for us in Scratch. In C, you have to do it yourself. But you have to be a little more particular, too. It turns out that in the world of C, you can't just have variables. You have to tell the computer in advance what type of variable you want. And specifically, I'm going to tell the computer that the type of variable I want is going to be a string. And the convention for doing so is you literally write the name of the type that you want, string being the only one we've seen thus far. Then you write the name of the variable. And then again, to assign a value to that variable from right to left, we have to use the single equal sign here. And now just a quick pause. Brian, if we could call on someone for this. Even if you've never programmed before, if you've taken to heart one of my pieces of advice earlier, I'm still missing something. How might I want to finish the translation of this Scratch code to C on the right-hand side? What is missing from what you can tell? If you've programmed before, odds are it'll jump right out. If you've never programmed before, you'll have to think back on what I said earlier. Jacob, what do you think?
Semicolon.
Exactly. There's just one single stupid semicolon missing at the end of the line, which is necessary to make clear to the computer that this is the end of this thought. And I sort of impugn it as stupid because honestly, one of the biggest frustrations when learning how to code, as will now happen today and this week and beyond, is initially you're going to forget stupid things like the semicolon, or you're going to forget a single quote mark, or a parenthesis, or things like this. And the most important advice I can give today is just try not to get frustrated by those kinds of stupid things. It's a lot more interesting, it's a lot more useful in life to understand functions and loops and conditions, and not to let yourself get frustrated by the more minor aesthetic things that honestly will just come with practice. So if the very first mistake you make is missing a semicolon and it takes you 10 minutes, an hour to figure out what is wrong with your code, totally normal, and those frustrations go away quite quickly in time. So we then have this translation of one function to another. Where else can we take it from here? Well, let's take a look at one other translation that we used after that ask block. Last week, after we asked the human their name, as by providing an input to the function and getting some output, we then proceeded to do something with the return value or output of ask. Again, we asked the human their name. Scratch magically last week put your name into the answer variable. But then I did something with it. And this is what I mean to distinguish side effects, which just kind of happen to you, like something printing on the screen, like the cat saying something out of its mouth, versus a return value, which is a piece of information, like a name a human has typed in, being stored somewhere where you, the programmer, can make use of it later. It's not happening to you. It's being handed to you for subsequent use. And last week, in order to say hello, comma, world, all in one breath, so to speak, we kind of had to stack these puzzle pieces on top of one another, making the output of join the input of say. In C, this is actually a little easier, even though it's some new syntax. Again, printf is going to be the analog for say, and we've seen that a moment ago. We're still going to have the parentheses. We're still going to have the semicolon. So what goes inside now the input? How do I provide hello, comma, answer to C? Well, I'm going to go ahead and do hello, comma, in double quotes. But then this strange new syntax here, %s. This is what we're going to call a format code, and hence the f in printf. Printf doesn't just print things. It can print format codes as well. And this is just fancy syntax for saying plug in some actual value here. Don't print out %s literally. This is a placeholder for what will be S, a string. Well, what do I want to put there? Here's something new too. In Scratch, if you had two inputs to a function, you would have two ovals like this and this one here that you could either type words or numbers into or drag variables into. In C, there's no notion of ovals or graphics at all. So instead, we're just going to go old school and just use a comma. If you use a comma in between the parentheses as the arguments or inputs to a function, that's going to separate the one on the left from the one on the right, thereby being analogous to having two ovals in the world of Scratch. Now, there's something that's potentially a little visually confusing here. There's actually two commas here, of course, and here. But notice the important detail. That first one, that's an English grammatical comma that I've put inside of my quoted string, my quoted phrase of text. That has nothing to do with programming. That just has everything to do with English. The fact that this comma is outside of those double quotes, though, means it's significant in this language called C, and it separates first argument from second argument. And so in this way, do we have the ability now to also say something on the screen using printf in this slightly new way. So let me go ahead then and do this for real. Let me go back to CS50 IDE, and I'm going to go ahead and go back into this program here and consider for just a moment how we can improve upon this very first program, which literally just prints hello world. Not that interesting. I can run it all day long. It's going to say the same thing. How do I now get input from the user? Well, it turns out that I can simply enhance this code a little bit. Let me go ahead and, per the translation of Scratch earlier, let me do something like string answer equals get underscore string, quote unquote, what's your name? So I'm literally typing out what we saw in C a moment ago. I'm going to remember my semicolon over here. And then I have to change this second line of code now to not say hello, comma, world, but instead to say hello, comma, %s. And then outside of the double quotes, I'm going to do a comma and then provide literally the word answer, which is the name of that variable. But I'm not quite done. And this is a little subtle. And invariably, you'll forget this at some point too. In order to use getString, I have to use this thing called the CS50 library, code that the staff wrote that you don't have default access to. And in order to do that, I need to add one line of code that we'll explain in more detail in a little bit. But for now, just take it on faith that by adding this line of code at the very top, include cs50.h, that will now give me access to the getString function, which I otherwise wouldn't have access to. All right, now I'm going to go back to the terminal window and notice the dichotomy here. If I just run /hello sort of enthusiastically, let's see what my new program does, I'm about to be unfortunately disappointed because it still says hello world. And you might realize intuitively what the problem, of course, here is. I haven't actually recompiled the code. And so anytime you make a change to your code, it does not suffice to just save the file via file save or control or command S. I need to recompile it. And to recompile my code, that's not such a big deal. I just type make hello, enter, cross my fingers that there's no yellow or red scary text. This is all good. It seems to have compiled into machine code. Now I can retype /hello and enter. And you'll see now my program is running and waiting for me. Let me go ahead and type my name, David, enter, hello, comma, David. Let me go ahead and run it again after clearing the screen. Let me run it again. And this time, let's say my name is Brian, and I see hello, comma, Brian. So quite similar to what we did in Scratch, but now we're more powerfully doing this all thus far via my keyboard alone. All right, so that was a lot. We wrote hello world super quickly off the top of my memory and then enhanced it to now take input from the user. Let me pause here if there are any questions. You're welcome to ask via chat for either staff or classmates to answer. But if you'd like to raise your virtual hand in Zoom, please feel free so that I can clarify or expound on anything here. Yeah, question from Ryan.
Yeah, I'd asked this in the chat, but so the string before the answer, that's not the name of the variable. So you could hypothetically make it like you could make it like string A or string anything else. It just matters what comes after. String is the name of the variable.
Exactly. Really good question. In the world of Scratch, you were required to use the variable called answer. In C, we have the complete flexibility over what we want to do. So as Ryan proposed, I could change my variable's name to just A for short. I would have to change it elsewhere too to make clear that the variable being used is the same one by a different name. That's perfectly fine. But here's where we now get into a matter of of better style, having a variable called just a doesn't really lend itself to the readability of your code. I might now glance at my code and be like, what is the variable a? It's a little better when it comes to writing good code to actually be more verbose and using an actual word like answer in this case. Indeed, even though I keep describing x and y and z as the go-to variables for a mathematician, those really say nothing outside the context of like a Cartesian plane. So in a program that you write in C or Scratch or anything else, using descriptive variable names is a matter of good style as well. Jonathan, over to you.
Yeah, just a quick question. How come we have to compile the code every single time? And unlike different IDEs, which if you just run the code, it automatically compiles, why do we have to manually do it?
Yeah, really good question. Why do you have to keep recompiling the code? Short answer is just because. This is the way C is. It's an older language, decades now old. And so back then, everything was very deliberate. User interface was not the top priority. Performance instead was, for instance. And so nowadays, there are fancier integrated development environments. And some of you might have used things like Codecademy Online or code.org, where there's very often like literally a play button that you can just click in the user interface, and it just plays your program or runs your program. What we're doing in this class is showing you what those buttons are doing. So if you do use an environment like that that seems to automate this, it's still happening. But for our purposes, certainly at the beginning of the semester, we're going to do it manually ourselves. Later in the term, when we introduce a different language altogether, for instance, Python, then kind of, sort of, you don't need to compile anymore. But more on that in a few weeks. Good question. Sophia, over to you.
I had a question about, I noticed in the source code that there's a backslash like n at the end of the string. Is that necessary for every time, even if it's just one line?
Really good question. This \n that you're seeing elsewhere, a bit of a spoiler, but yeah, let's go ahead and fix this problem that we've seen, even though I'm kind of ignoring it. You know, this now gets a little particular, but this looks kind of stupid, honestly. It says hello, comma, Brian, tilde/$. Like, that is not my intended output. I literally only wanted to say hello, Brian, or hello, David. This visual artifact here, the $ and the tilde and the slash, have to do with my terminal window, this command line environment that I'm using. And honestly, just to be a little nitpicky, frankly, it should probably be on a new line. It should just be on its own line so it's not confused with my own output. And as Sophia notes, there is a solution to this. But again, per last week, you need to be, when writing algorithms and in turn code, you have to be super precise. Nowhere in my code have I told the computer to move the cursor to the next line. So I can do that explicitly by doing \n immediately after the %s, but still inside of the double quotes. This is shorthand notation for what would be telling the computer, move the cursor to the next line. Now, you might think that, well, why don't I just hit enter like this? And even though this all might be new to most of us, suffice it to say that this just feels like it's going to get messy quickly. If you start hitting enter in the middle of your code, that's probably not the right solution. So instead, programmers years ago decided to come up with shorthand notation like \n, otherwise known as an escape character, that signals to the computer, put a new line here. So \n is new line. And let me go ahead and recompile this after saving my file. Let me go ahead and do make hello.